Part 2 of 1.2 Atherosclerosis from Houston Wayne. I don't know, where's he gone?
I'm here. I'm here.
He's there.
I had a little trip.
Was it a nice trip?
It was alright. From this book.
Yes. So it all centres around something called atherosclerosis. So, what's that?
Well, it isn't just a scary word. It's a type of cardiovascular disease. Very nice. And it's in fact the focused disease of this topic, topic 1.
Yeah.
And it's all to do with the increased blood pressure in the arteries and the chain effect. Really.
Yeah, and we have to go through the chain effect, what chain effect is, and all that jazz. But first,
there's a new spelling.
Yeah, you get it wrong, you die. So,
atherosclerosis
starts with an A.
Athero, A-T-H-E-R-O. Athero.
Sclerosis.
Sclerosis. S-C-L. It's for the sclerosis.
If you still do phonetics. And that's
atherosclerosis.
That's quite a big word. Now it's in the process of how and why it's formed. So, to start with, mentioned before, arteries only like a certain type of pressure. Quite high, but if it gets too much higher, it causes damage.
So that'll be the first step, is actually the damage. That triggers off atherosclerosis.
So where is the damage, Wayne?
Well, being very specific on your arteries, it's actually on the endothelium cell, the endothelial cells, the endothelium. And that's where the damage occurs. You can sort of imagine it as firing lots of blood through a tube is going to cause friction. It's like trying to put too much water through a hose pipe. You can imagine it would elastic above its limit and then
water everywhere.
Except we try to repair that.
You try to mix that, so lots of blood cells go in, but white ones.
Yeah, you should be familiar with the idea that white blood cells are there to fight pathogens.
Yeah, they're your immune response. Yeah. But they try and help anyway, and they cause something called the inflammatory response, which isn't very helpful, but to some extent.
And that would in fact be your marking points, the inflammatory response. And it's where the white blood cells, they all pile up, they try and fix these friction holes, and they drag in cholesterol and fatty acids and stuff from the blood.
Yeah, and this causes a fatty deposit, which is bad. If we draw a cross-section of our artery, but this is just the lumen,
Imagine it's zoomed in. This is the lumen. That's the endothelium being damaged.
Yep. And then we have this deposit that forms, which is called
an atheroma, another key word.
Yeah, one you have to know.
So essentially, all of this part, this atheroma, is useless. You can't fly blood through a solid, so it's reducing it to just this area.
Yeah, which increases the pressure more. Then more bad stuff happens.
Yes.
Lots of things are attracted to this.
Yes, like calcium salts and fibrous tissues. So they all come here and they form something called a plaque, which is like another circle on the circle to reduce the circle.
Yeah, well put. This all leads to more hardening of the artery, makes it even less elastic, and it just keeps getting worse. But that's step 4.
Yep. So we've got step 3 would be the atheroma forming due to the inflammatory response being a bit rubbish. Then plaque, you have to be able to spell plaque. It's not P-L-A-C-K, it's P-L-A-Q-U-E. So if we draw that on here, like I said, it's another circle on the circle in a circle to make the circle smaller than the original circle.
So it could maybe occupy this area.
And now that's all useless.
Which means we're going through this tiny area.
And even worse than that, it's less elastic. So although this takes up lots of room and puts it in a lower area, it can still stretch. Now it can't even stretch. It's smaller.
So the high pressure keeps getting worse, so this keeps getting worse. It's called positive feedback.
Bit confusing.
Yeah, positive feedback is bad, generally.
Despite the word positive.
It just means it keeps going in the same direction.
Yeah.
Which is...
If we've got a graph of getting worse a long time or something.
It keeps going up. So with this higher pressure, it causes even more damage. Okay, so
remember, this is only a cross section. It would keep going down as well as being on the other side.
So it causes high pressure throughout, and this causes more clotting to happen, and that can cause blockages.
Yes, because if a clot was to form on the plaque on the atheroma, then it could sort of form starting off across there somewhere, and then clot on a clot, until all of this area.
We just block it completely off, and well, that means blood can't get any further. So these cells after it will just die.
Yes.
This is especially bad in the heart
and the brain. Both are as dangerous as the other.
In your heart you have coronary arteries, which are arteries that supply the heart itself with blood. And if they get blocked, you have a heart attack.
Yes. Myocardial, what's it called?
Fartation?
Something like that, isn't it?
It's,
You don't need to know that.
You just need it's a heart attack. And in your brain you can form an aneurysm, which is equally bad.
And it can happen in the rest, like your foot cannot be supplied, your foot can die.
Yeah.
And stuff like that. The cells there become permanently damaged, but most serious in the heart of the brain.
So this is called atherosclerosis. You also have to know how this bit happens.
The blood clotting, so let's get on to that now.
Strike on. So,
Blood clotting.
You got to know how it happens, where it happens, and why. So if you had a cut, and you're bleeding, you notice it stops. That's because a blood clot's formed, and it heals it, and then it all heals, and it all dissipates, and it's all lovely.
Sometimes, in certain people, they don't have clotting factors.
No.
So it would keep bleeding continuously, which is a real problem.
It is a real problem, because if it was a big cut and bleeding a lot, you could die.
Very quickly.
So, you have these bandages that we've actually seen in the question.
There's actually an exam question we came across.
Yeah.
This bandage around, I'm saying you have an injury in your arm.
Yeah.
It's got the clotting factors that people might not have.
Back, so this then forms a clot over the injury, and they're fine then.
Yeah, and that actually came up, and that's applying the knowledge we have here.
Yeah.
So don't think it's enough just to memorise, you need to sort of understand,
Yeah,
which is why we're
understanding
going
is
for it.
important. So, we're going to use the example of an artery.
Yeah. This all could happen in a vein. It's not impossible.
No.
It's just they deal with such lower pressures, it's so unlikely. Whereas this can happen all the time.
Yeah, it could happen anywhere in your body, in fact, if you have an external cut, but this is more sort of internal stuff.
Yeah.
So, if we have high pressures and there's a bit of damage here.
In this artery you've got red blood cells, denoted by a circle.
Yeah, they're just sort of flowing through, they carry your oxygen, and you have something called platelets.
You're going to do with an asterisk.
Yeah. What does the platelets do, Wayne?
Well, they're all attracted to this part. They all sort of see it and think, oh, I better fix that, and then they go do that.
They all stick to it. So when they stick to it, they do something for quite a while, and it forms something called a platelet plug.
Yeah. And these are still floating around at the second, but when it's formed a plug...
Yeah, it starts pulling them in, and then draw our final part.
Yep, this is the end.
So we have our injury, and then we have loads of platelets, platelet plug, loads of red blood cells being put in, and they're being held together with something called a fibrin mesh.
And that's a clot. That's what forms a scab.
And then you heal, and then it all dissipates, and it's all lovely.
Yes. So, how do we get to this fibrin mesh trap?
Yeah, so I'll annotate it. It's a bit more simple, not quite as simple as just knowing the pretty pictures. Unfortunately. So we have a insoluble fibrin mesh.
Yes. Insoluble fibrin mesh. Okay.
Yeah. And we have to get to the fibrins. This isn't just floating about, otherwise you'd have something insoluble in your blood, and that's not so handy.
So we have a soluble, but not as useful,
form, which is called soluble fibrinogen, and this is converted to fibrin. But how does that happen?
Well, because that's going to go to that's going to be a final product. This combines with something called thrombin.
Yeah.
That's how it, because it doesn't just literally turn from that to that.
It uses itself as a reaction, reacts to thrombin, but again, that's not found in the blood on its own either.
So we're going to have to go back another step.
We go back all the way to the beginning. Right at the beginning, there's a few things that are in the blood just sort of jamming, and these are calcium ions.
So Ca2+.
Yep, and vitamin K.
Yep, and they go to the emergency site.
They do. And something is jamming in your blood, and that is
thromboplastin. That's released from the platelets when they stick to this thing. It's not just floating per se, it's with the platelets.
So that's
thromboplastin.
Spelled like it sounds.
Yep.
It's
just quite a long word.
Yeah.
And that combines with something to make this thrombin, which then combines with the soluble.
Which is caused by them joining in. But what is the thing?
Prothrombin. So it's spelled the same as that, but pro
in the front.
Before.
And that is found just sort of swimming about in your blood. So you also not only have to know the diagrams and understand what happens, you have to follow this process to make the mesh which holds it all together.
Yep, and that's blood clotting pretty much.
That is pretty much blood clotting. This isn't always helpful. As I mentioned before, if it happens in atherosclerosis, it can cause a complete blood clot.
Yeah, and to stop, anything beyond that would just die, and obviously it can cause a heart attack.
Or it could just make it a very, very small trickle of blood that gets through.
It doesn't have to close it completely.
No.
And if that's in your heart with the coronary arteries, that can cause a slightly different problem to a heart attack.
It can. What it does is your coronary arteries in your heart doesn't have enough oxygen to respire. So it has to respire anaerobically.
Yes.
And this releases lactic acid, and that causes quite a lot of discomfort.
This causes you chest pain, and that's a special word at A level.
It is, and that's called angina. This is chest pain associated with lactic acid in your heart.
So key word you have to know there.
Yeah.
I can go on to sum up, but this is blood clotting.
This is blood clotting. You need to know the process quite well and understand it and apply
You
it.
need to know the fibrin mesh trap is insoluble and is made from soluble fibrinogen from thrombin and prothrombin and thromboplastin and CO2 plus ions and vitamin K released from platelets and the red blood cells and look.
Yeah.
So let's go sum up all of this stuff.
Alright.
We'll actually sum up part 1 as well right now.
Yeah, do both of them. Alright. So, summary of 1.2.
Yep, part 1 and part 2.
Both of them.
Right back in part 1.
Yeah, right back at the beginning we had the structure of the heart and labelling it and all that jazz.
Yep. We came up with a mnemonic.
We did.
I'd advise you to come up with your own.
Yeah, different ones work for different people. Ours is
bizarre.
Terrible.
Yeah.
But whatever works, and you can use the plus square thing to draw diagrams, and you've got to know vaguely why the structure of heart is how it is, what the function of the valves, and that the left side is much thicker because it goes around the whole body.
So you've got things got to pump further, it's got to be much thicker.
Under more pressure. Then we went on to vessels.
We did arteries and veins, the comparisons, arterioles, venules, capillaries.
Yeah. Again, valves in veins, not in the other. Apart from that, they're pretty similar, apart from the size of the lumen.
Yeah.
Yeah.
There's also something called collagen, which we didn't mention.
No, and that's on the outermost layer is made of connective tissue made of collagen, which holds it all together.
You might notice if you go back to part 1, I drew it, and then we didn't label it.
Yeah, we didn't label that extra layer. That had collagen.
Yeah. So what do we have after that? We went on to the cardiac cycle.
We did, and you got to know about systole and diastole. Systole being contracting, diastole being relaxing. There's 2 types of systole.
Yep. Atrial and then
ventricular. Yeah, makes sense. Goes from top to the bottom for anybody and again.
Yeah. Quite quickly.
Quite quickly. And the noise of your valves is noise of your heart made from the valves.
Yeah. We then went on to part 2 and we started this video.
Which atherosclerosis.
A new thing, a new word.
New word, you need to spell it.
The focus in terms of CVD.
And how it applies to CHG if it affects coronary arteries.
Coronary arteries.
Got there in the end.
Then we got on to blood clotting.
Yeah.
It happens quite a lot and very, very useful, but unfortunately happens with atherosclerosis just to top it up and make it worse.
Yeah, it's lots of positive feedback involved, you don't know all that. Yeah.
And that's part 1 and part 2 summed up, and that's 1.2.
There you go.
We'll see you at topic 1.3 then.
We will. Alright.
Roll the credits.